Welcome once again to our math class, a review. This time we're going to be reviewing Chapter 5, Lesson 1 for our 6th graders. We're going to be going pretty quickly because you should have most of this in your notes. There is one section a little bit later on that's a bonus section that's only available if you're watching this video. We didn't talk about it in class. So let's begin with some quick questions and answers. What are integers? Integers are positive and negative whole numbers and 0. Now notice this. When you take notes in class, you should be using some easy to remember abbreviations. Here in this video and in other places, we're going to often use a capital N or a small n to represent a number, any number. We're going to use what looks like a tic-tac-toe sign with or without the letter S after it to represent words and numbers. And we'll sometimes put a slash through a 0 to represent 0, or if people might be confused whether it's an O in the alphabet or a 0. What are opposites? Opposites are numbers on a number line that mirror each other. That means they are the same distance from 0. 2 and minus 2 are the same distance from 0, so they are opposites. Minus 8.5 and 8.5 mirror each other because they are equal distance from 0 on a number line. So what is a number line? Well, it's a scale or a chart. It's a line with numbers on it. What direction do number lines go? Well, they can go from left or right. We call that horizontal. They can also go up or down. We call that vertical. Larger values on a number line go to the right of horizontal lines and to the top of vertical lines. Smaller values are to the left of horizontal lines and to the bottom of vertical number lines. Well then, what is a coordinate plane, which is sometimes called a coordinate grid? It's a graph or a graph paper with a horizontal and a vertical number line, and these lines cross each other at 0. We call that point the origin. What are quadrants? Quadrants are areas on a coordinate plane. There are 4 specific areas that are created by the x and y axes. We number these quadrants 1, 2, 3, 4, starting in the upper right-hand corner and then moving counterclockwise. What are rational numbers? They're numbers that can be written as a fraction using whole numbers. So in other words, 3 over 1, 3 and 1 are whole numbers. That is a fraction, and it is equal to 3, so 3 is a rational number. We can represent that by any whole number over 1. Also, any number, whole number, over any other whole number makes a rational number as long as the numerator and the denominator, in this case a and b, are integers, and the denominator, of course, cannot be 0. We have 2 kinds of decimals that we think about quite a bit. One is terminating and one is repeating. So what are they? Well, terminate means to end, and a terminating decimal ends. For example, 1/2 equals 0.5. It's not 0.5 and something else, it's just 0.5. 3/4 is equal to 0.75. Those are all terminating decimals. Now, of course, repeating decimals don't terminate. They don't end. At some point, they go on forever and ever with the same digit or pattern of digits. For example, 5/9 is equal to 0.555 on forever. We write that as 0.5 with a bar over the 5. That is what we mean when we say bar notation. 4/3, a rational number, could be written as 1.3333. And we would then write that in a shorter form as 1.3 with a bar over the 3. Now this is an interesting one. 4/7 is 0.57142857142857, and on and on and on. So when we write that, we would write it as 0.571428 with a bar over all of those numbers. One of the things we see on many, maybe even most number lines is a 0. So what different things can a 0 mean, or can it represent in a story problem or on a number line? Well, it could mean a lot of things. It could mean that we have no gain or loss, the beginning or starting point, an amount of 0. If a story problem talks about a budget, you have $53 budgeted to buy something. When it's all spent, we're at 0 on the number line. If you would happen to overspend your budget, spent more than you were allowed, then you would move to a negative number on the number line. In weather, we often hear on a weather report, this month's temperature was about 3 degrees above or below average. Well, average in this case is 0. On a number line, we would put 0 at whatever that average temperature is, and then we could note above and below 0 by positive or negative numbers. In football, 0 might refer to the line of scrimmage. See what others you can think of on your own. Pause the video and see what you can think of on your own. If you have a number line that doesn't have numbers on it yet, where do you put the 0? Pause this video for a minute and think about that. Where do you put the 0? That's right, you can put it anywhere you want as long as it's helpful to you. You might put it in the middle, you might put it to the left, you might put it sort of toward the right, or as in the case of the number line on the right, the 0 is on the number line, but it's below what we can actually see. How can you use integers to represent data? Well, that seems pretty obvious. You put them on number lines, coordinate planes, and other graphic organizers. What integers represent gain or increase, and what integers represent loss or decrease? Positive integers represent gain and increase. Negative integers represent loss and decrease. In story problems and in real-world situations, what words represent gain or increase or loss or decrease? Well, here are some of those words, not anywhere near all of them. But if things get better, or if you have more, if you're above average, or if you have gain, that is increase or gain. If you have things that are smaller, withdrawn from, as in a checkbook, spent or decreased, that represents loss or decrease. Here's a bonus. This wasn't given to you in class. You only get this if you watch this video. Here are a lot of vocabulary words about integers that will help you relate them to story problems. Pause the video, take your time, and enjoy these. Let's end this review with a quick definition. What is a data set? A set of data is a group of related data. So anytime you see the word set, think of a group of related things. For example, positive even numbers are 2, 4, 6, 8, and we write that with little braces around 2, 4, 6, 8, and because this continues forever, we put 3 dots after it. This is an infinite set. It goes on and on and on. The hour numbers on an analog clock, however, are a finite set. There are 12 of them. Again, we can use the braces around the numbers, and we start 1, 2, 3. Then we can put dot, dot, dot to show that it continues, and then we put 11 and 12 to show that that's where the set ends. And that ends our quick review for 6th grade math, chapter 5, lesson 1.